in this lesson, we are going to solve this question that I have on the screen, which says that we should find the resultant force for this system of forces here using the force triangle approach. The FTA means force triangle approach. So let's look at how we are going to do this. Okay, so you see that in this case we have more than two forces here. Okay, so you can't just draw a force triangle since you have more than two forces here. So for that reason, you are going to draw force polygons. Okay, from there we continue with deriving triangles from the force polygon. Then we find for the resultant force. So let's look at how this is going to be. So I'm going to draw a force polygon using this system of forces here. So I'll start with F1. Okay, remember that F1 doesn't have an angle, so it lies on the positive x-axis here. So you have F1 to be equal to 40 Newton. And then you have F2 making an angle of 30 degrees with the horizontal. Okay, so let me bring this dotted lines here, and then let me draw F2. Okay, so this is F2, and then that has a magnitude of 60 Newton, and then it makes an angle of 30 degrees with the horizontal. Okay, so from there I'm going to have F3. Okay, and then F3 makes an angle with the vertical axis, so let's do that also. So I'm going to draw the axis here. Okay, so this is the vertical axis, so let's draw F3. Okay, so this should be our F3. Okay, and then that has a magnitude of 100 newtons. And then it makes an angle of 60 degrees. 60 degrees here. Okay, so this is what you have now. So now you see that the polygon is not complete. You don't have a polygon yet. So what you have to draw now is the resultant force. Okay, so that will be the side that will close the polygon. Okay, so this will be the resultant force. This is the resultant force. Okay, so now you have a polygon here. Okay, so now from this polygon here, you are going to draw triangles. Okay, so you are going to derive two triangles from this polygon. So let's look at that. So you're going to have something like this. Let me do this better. Okay, so you have something like this here, and then I will extend this line. Okay, yes, this is okay. So I'll name this angle here as alpha, and I'll name this angle here as beta. Okay. Alright, so we have two triangles here. So I have this to be the first triangle, and I have this to be the second triangle. So now you can apply the first triangle approach, or we can use the first triangle approach. So I will first consider the first triangle. So let's look at that. So I have F1 here, then that's 40 newtons, and then I have F2 here, and then that's 60 newton, and it makes an angle of what, 30 degrees here. Okay, so now what's left with is the resultant force for these two forces, which is F1 and then F2. So we have that here. So I'll name this as R1. Okay, this R1 here is different from this R. Okay, so let's take note of that. This R1 here represent this red line that I have here. Okay, this red side here. Then that will be the resultant for F1 and then F2. So let's go ahead and then find R1. We can calculate for the angle here. Okay, then we know that angle in a straight line sum up to 180 degrees. So when subtract this 30 from 180, you're going to get 150 degrees here, and then that's the angle opposite to R1. So you can go ahead and then find R1 using the cosine rule. Okay, so I'm going to have R1 to be equal to the square root of F1 squared plus F2 squared minus 2 multiplying F1 F2 cosine of 150 degrees. Okay, so this is what we have. So now let's substitute in our values. So we know the value of F1 and then F2, so let's put them in. So this is going to be 40 squared plus 60 squared minus 2 multiplying 40 times 60, and then also multiplying cosine of 150 degrees. So what you have to do now is to simplify what you have. So let's square 40. Okay, 40 squared give me 1600, and then 60 squared give me 3600, and then what you have here. Okay, when I multiply all the values there, that give me, so I have minus, and then that give me minus 4156.9. Okay, I multiplied everything together. So now let's further simplify. Because of the two negatives that we have there, we're going to have a positive sign there. So we're going to have, let's add the 1600 and then 3600. That gives us 5200, and then you're going to have plus 4156.9. So let's find the value of this. So we're going to have this to be equal to, let's sum up everything, plus 5200 plus 4156.9, and that'll give me a value of 9356.9. So let's take the square root of that, and then that gives us R1 to be equal to 96.73 Newton. So that's the value of what? R1. I will write this down here. That's 96.73 Newton. So that's R1. So now what I'll do is that I'll find the angle alpha, okay, which is this angle that we have here. And then let's look at how I'm going to find this angle. So that's the angle opposite to F2. Okay, angle alpha is opposite to F2, and then for F1 we don't know its angle. Okay, and then for R1 we know its angle to be 150, and then we know the value of what R1 here. So to find alpha, we're going to use R1 and then F2. Okay, we will use R1 and then F2. So let's look at how you're going to do this. So you're going to apply the sine rule here. So that will be sine of alpha divided by F2, that's 60, and then this should be equal to R1, which is 96 point, sorry, that's not R1, that's sine of 150 degrees. Okay, sine of 150 degrees divided by R1, which is 96.73. So you can simplify this further. We're going to have sine of alpha to be equal to sine of 150 degrees divided by 96.73 times 60 newtons. Okay, so let's simplify this here. So sine of 150 divided by 96.73 times 60. This will give me a value of 0.3101. So that will be 0.3101. So I'll then take sine inverse of this. I'm going to have alpha to be equal to the sine inverse of 0.3101. So let's see what that will give us. 0.3101. So this will give us a value of 18.1 degrees. So that's the value of alpha. So let's write this here also. That's 18.1 degrees. Okay, so now let's consider the second triangle. Okay, let's consider the second triangle. So now that we know R1, we can now find the resultant force, which is R. So let's look at how you are going to do that also. Okay, so let me draw the second triangle. So I have this to be, let me make this a little bit slanted. Okay, so this is R1, and then I have this to be F3, okay, which is 100 Newton. And then let me reduce the length of, okay, this is okay, let me leave it that way. This is R1, that should be equal to 96.73 Newton. So this will be the resultant force. This will be the resultant force R, okay, which is the actual resultant force that we want to find. Okay, and then you have the angle beta here. Let's extend this. Okay, so this is just some an extension. What I'm doing here is just an extension of the first triangle. Okay, so that I can bring the angle alpha here, which is 18.1 degrees. Okay, so when I do this, you see that we have an alternating angle here. So this point is also going to be 18.1 degrees. Okay, so let's take note of this. And then we have 60 degrees here. So what then happens here is that this angle here is going to be 90 minus 16, and that will give us 30 degrees. Okay, so now we want to find R1, and you can use the cosine rule because you know the angle opposite to R. Okay, we are finding R rather. We can now find R because we know the angle opposite to it. So now the angle opposite to the resultant force R will be 30 degrees plus 18.1 degrees, and then that gives us what, 48.1 degrees. So we are going to apply the cosine rule here. We are going to have R to be equal to the square root of R1 squared plus F3 squared minus 2 multiplying R1 F3 cosine of the angle, which is 30 degrees plus 18.1 degrees, and then that gives us 48.1 degrees. Okay, so now let's substitute in our values. So we're going to have 96.73 squared, okay, plus 100 squared minus 2 multiplying 96.73 times 100, okay, then cosine of 48.1 degrees. So now let's simplify. So I'm going to add 96.73 squared and then 100 squared. So let's do that. So 96.73 squared plus 100 squared. So that'll give me 19356.69. Okay, and then minus 2 multiplying 96.73 times 100 multiplying cosine of 48.1. So that'll give me 12919.9. Okay, so now let's simplify this here. So that'll be 19356.69 minus 12919.9. That'll give me 6435.9. 36.79. Okay, so now let's take the square root of that. This will give us a value of 80.23 Newton, and then that will be the value for the resultant force. So now that we know the resultant force, we will have to calculate for the angle it makes with the positive x-axis. Okay, because this is the resultant force, and you know it makes an angle with this axis here, okay, or the horizontal, because you can get the resultant when you move in the anti-clockwise direction here. Okay, so this will be the angle for the resultant force. So let's look at how you're going to calculate for that angle. I will name that angle as theta sub r. Okay, and theta sub r will be equal to alpha plus beta. Okay, that's theta sub r, and then that will be the angle that the resultant force makes with the positive x-axis. So all you have to do now is to find beta. Okay, all you have to do now is to find beta. So let's look at how you are going to find the angle beta. We can apply the sine rule here to do that, to find the angle beta. So let's do that. Okay, so we know the resultant force, and then we know the angle opposite to it, and then we know that the force opposite to angle beta here, the force opposite to angle beta, okay, let me, I think I made some mistake there. Okay, let me join this here. Okay, and then we have beta here. Okay, so the force opposite to the angle beta is F3. Okay, so let's apply the sine rule to find the angle beta. So we're going to have sine beta over F3, which is 100 Newton, and then that should be equal to sine of 48.1, which is the angle opposite to the resultant force, divided by the resultant force, which we got to be 80.23. Okay, R was 80.23 Newton. Let's write that here. So sine of beta should be equal to sine of 48.1 divided by 80.23 times 100. Let's simplify this. So sine of 48.1 divided by 80.23 times 100. So that would be equal to, that's 0.9277. 0.9277. So we will take sine inverse of that. So the sine inverse of 0.9277, that gives us an angle of 68.1 degrees. So we know alpha to be 18.1. So let's do the substitution here. We're going to have 18.1 degrees plus 68.1 degrees. So 18.1 plus 68.1. So we're going to have the angle to be 86.2 degrees, which is this angle here, from this point here to this point here. Okay, that's the angle that the resultant force makes with the positive x-axis when you measure in the counterclockwise direction. So guys, that's all for this video. Thank you very much for watching. Please make sure you like and subscribe.